In this video, we're going to learn how to differentiate terms with positive indices. Now, at the end of the last video, we learned how to differentiate an expression from first principles. So you may remember that. So just a reminder of a few things here. F dashed of x is the derived function or the derivative of f of x. And a reminder as well that the derivative represents the rate of change of the function and the gradient of the tangent to the graph of the function. So those were the three really important things that we need to remember as we go through this. So we started with this at the end of the last lesson. So if f of x is equal to x squared, we learned that f dashed of x, that's the derivative, was 2x. So I'm going to take you a bit further and tell you that if I have f of x equal to x squared plus 3x, the derivative is 2x plus 3. Now I want you, as I go through this sequence, to have a look at what is the same, what is different, what is changing, and see if you can see any sort of pattern happening. So if f of x is x squared minus 3x, then f dashed of x is 2x minus 3. So you can see in each of these so far, hopefully, that we've got the consistency of this x squared, and that obviously differentiates to the 2x. You can see we've got this 3x here and negative 3x, and those differentiated to positive 3 and negative 3. So the sign is obviously important here. Hopefully you can see x squared has gone to x to the power 1. So we're actually losing a power here in a sense. We're losing 1 from the exponent, so that's interesting. And the same happens here. We've got x to the power 1 here, and remember, if we've just got a constant, that's actually x to the power 0. So the same thing is happening there. Let's have a look at another one and see if the same thing happens. So if f of x is x squared minus 5, that just gives us 2x, and that's the same as the first one. So the constant on its own seems to disappear almost. What about this one? So f of x is x squared minus 3x minus 5, and the derivative then is 2x minus 3. So that same derivative was here for the x squared minus 3x. So you can see that it appears that the constants are disappearing, doesn't it? Look at another one. Now this time, instead of x squared, we've got 4x squared, and that's become 8x. So this 4 has obviously had an effect somehow. Oh no. F of x is equal to 4x cubed minus 3x minus 5. And this time we've got 12x squared minus 3. Now if we have a wee look at this 4x cubed, that became 12x squared, so we can see that there's 1 being subtracted from the exponent again, so we already discovered that up the top. But this 4 has become a 12, and here this 4 became an 8. Suppose if we look at the exponent, that was 2 multiplied by 4 would give us 8. 3 multiplied by 4 gives us 12, so it must have something to do with the exponent multiplying the coefficient of the term. So let's just summarise everything I've just said. So if we have f of x equal to x to the power n, then f dashed of x is n multiplied by x to the power n minus 1. So we talked about how the exponent appeared to be 1 less in the derivative, so we are subtracting 1 from that, so that's fine. And then we talked about at the end here, we talked about the power multiplying the coefficient to get the 8 in this example and to get the 12 here. So again, that seems to be happening. The n here is becoming the multiplier of the coefficient. So that's quite important to remember that. So everything you differentiate will follow that pattern there. We'll have a look at some examples, some specific examples now to try and make this make more sense. So a function f is defined for x in real numbers by f of x equals x to the power 4. Find f dashed of x. So the solution then, we'll obviously start with what we have originally, f of x is equal to x to the 4. So we need to multiply by our exponent, which is 4. So f dashed of x is going to be equal to 4 multiplied by, now it was x to the 4, we need to take 1 off the power, so it's x cubed. So our final answer is 4x cubed. Now we'll have a look at a second example. We've got a function f is defined for x in real numbers by f of x equals 2x cubed. Find f dashed of x. So the solution then, starting with our f of x, now we've got our power here is 3. If we multiply that by the coefficient, we will get 6. And then taking 1 from the power, we'll get 2, so it'll be x squared. So we should have 3 multiplied by 2x squared, which gives us 6x squared, which is our final answer. So just now would be a good time to pause the video before the screen goes blank and take these examples down in your notes and then try the assigned exercise on differentiating positive terms with positive indices.